Hello and welcome back. If you are new to electronics in general, and transistors in particular, you may have stumbled across hFE parameter. This parameter tells us what is current gain when transistor is biased in amplification mode. By definition, current gain is ratio between collector and base current. When transistor is biased in cutoff or saturation mode, hFE parameter is meaningless. Although this is patently incorrect, it helps newbies to understand this parameter better. If you observe base current as input current, and collector current as output current, then ratio between these two currents is amount of amplification. This is an absolute value, meaning it has no measurement unit. If you want to learn more about this subject, we have a video explaining this parameter in details. It is episode 13 of this season. Now, you may have also heard about parameter called beta. There is an overlap and certain amount of ambiguity between beta and hFE. In short, beta is ratio between collector and base current for any unspecified transistor configuration. On the other hand, hFE is ratio of collector and base current for specific values of base current, base limiting resistor, current limiting resistor and power source, when transistor is biased in amplification mode of work. In general, both beta and hFE are used to describe the same thing, the ratio between collector and base current, when there is no small signal present at base terminal, and when transistor is biased in amplification mode of work. Also, colloquially, hFE is used to denote how many times transistor amplifies the base current. For an ideal transistor, this value is agreed to be 200 times. In practical use, in real life, hFE goes from 50 up to 1000 times, or even more. If electronics is your profession or just your hobby, you must have one of these, or similar one. They are called multimeters, and for this particular topic, we are interested in one specific type of measurement selector, and one specific port on multimeter device. You have guessed correctly, it is hFE selector and corresponding port. For this video we will select model in the middle, but you can choose and use any model you have. The principle is the same. Let's zoom in. Now, there are two rows of slots, the upper one for NPN, and bottom one for PNP transistors. If you put transistor in wrong slot, you won't get any measurement. Also, each row has 4 connectors for base, collector, and current terminals to connect to multimeter. This is pretty self-explanatory. What could be confusing is existence of 2 emitter connectors. Not all transistors have the same layout of terminals, so this extra emitter connector is there to ensure wide compatibility for many types of transistors, from many manufacturers. It is also important to mention that hFE port, for this particular type of multimeter, is compatible with TO92 and TO220 transistor form factors. Please consult datasheet for your particular type of transistor to learn layout of the terminals. For this exercise we will use ubiquitous and very popular NPN transistor 2N3904. Now we need to identify terminals on the component, or to put it more precisely, which one of the pins is collector, base and emitter. Here we have several different views of the NPN transistor. If we observe the component from top, we can see that head of the transistor has a shape of cropped circle. Let's face forward the component, so that flat edge faces us. Now, let's pull a page from datasheet so that we could identify and name terminals. Form factor of our component is TO92, and pins are marked 1, 2, and 3, starting from the most left pin, when flat edge of component faces us. From the schematics we see that pin 1 is emitter, pin 2 is base, and pin 3 is collector. So, let's put proper markings on out component model. Now, let's pull up the layout of hFE port from our multimeter, and observe top row of slots, the one dedicated for NPN model of transistors. What we can see, is that none of combination of slots matches layout of terminals for our transistor. What we can do is to rotate the component so that flat edge faces from us. Now the terminals are in order 3, 2, 1, which means that now, left-hand terminal is collector, the middle one is base, and right-hand one is emitter. This layout now corresponds to slots on hFE port on the multimeter, and we can use 3 slots, starting from the right hand on our hFE port to plug in our transistor. Let's select hFE setting on our multimeter, plug in the NPN transistor in proper slot, and switch on the multimeter. We have removed probes, just so that you can have an unobstructed view. You can also remove, or leave probes in, it doesn't affect reading whatsoever. Our multimeter displays value of 194. That is current gain of our transistor, or hFE parameter. If you remember from our previous video, hFE is ratio between collector and base current. This parameter is also colloquially called amplification of the transistor, or beta. To learn more about difference between beta and hFE, please see our previous video. We cover this topic in great detail. Please remember that hFE is current gain when there is no small signal present at base terminal. Now, this is the point where many of tutorials regarding this subject end. Okay, so you have your reading, the amplification of the transistor is 194, and that is it. Now, when you go and design your own circuit, you are left with impression that amplification of your transistor will be 194 times base current, in any configuration, with any value of power source, right? No, of course not. For those of you who have watched our previous video, you know that hFE parameter is dependent on base current and power source. hFE is current gain for one specific set of values of base current and power source, without small input signal present at base terminal. Change base current, or power source, and hFE also changes. So, logical question is, what is base current and power source used in our multimeter, or to be more precise, what combination of base current and what voltage of power source gives us this reading for hFE? No one knows, so let's measure it. First, we need to measure what power source is used for this measurement. Or to be more precise, we need to measure VCE, voltage between collector and emitter terminals. Next, we need to measure value for base current. And at the end, we need to see if base current is constant, that there is really no small input signal present at terminal. For the first part, we will use another multimeter, and set probes at collector and emitter terminals. This will give us value for VCE. Next, again, by using multimeter we will measure base current at base terminal, provided by multimeter. And at the end, we will use oscilloscope to observe shape of base signal, to determine if small signal is present or not. Although, this last part is not absolutely necessary, since by definition, we are measuring hFE, with capital FE, not hFE with small fe. Only problem is, that we cannot stick our probes directly into slots of hFE port on multimeter. We need the transistor in, and multimeter on, so there is no room to attach additional probes. Let's use breadboard, and some DuPont wires, to mirror the hFE port from multimeter onto the breadboard. This is our setup. We used 3 DuPont wires to mirror hFE port from multimeter to breadboard, and we plugged in our transistor, making sure that orientation and layout of pins correspond to layout of slots on hFE connector on multimeter. Our first job is to measure power source voltage, or to be more precise, voltage between collector and emitter terminals. We will use probes from second multimeter to directly probe voltage between emitter and collector terminal. So, to obtain value for hFE, out multimeter uses VCE voltage of 2.94 volts. Next task is to measure the base current. In order to do so, we need to rearrange our breadboard layout to accommodate multimeter probes, and put them between source of base current from hFE port and base terminal of the transistor. Let's do this. This is our new setup. We will position multimeter probes between base slot of hFE port and base terminal of the transistor. We will select DC current measurement, in microamperes range on our second multimeter. We measure between 10.1 and 10.2 microamperes of base current. DuPont wires from second multimeter are red and black one. So, this is our base current measurement. Now we have VCE voltage and base current parameters. All that is left to do is to verify absence of any small signal by using oscilloscope. We will attach oscilloscope probes between base and emitter terminal. This will give us shape of voltage signal going into base terminal of the transistor. So, our new setup looks like this. We can observe that voltage shape on oscilloscope display is straight line, so, there is no small input signal present. We have verified that this is correct measurement of hFE parameter. Now, there is no more mystery. To measure hFE parameter for NPN transistor 2N3904, our multimeter uses VCE voltage of 2.94 volts, base current of 10.1 microamperes, and there is no small signal present at the base terminal. Now, to verify measurements, we should measure collector current, and calculate the value of hFE for ourselves. So, let's quickly set up a new breadboard layout. This time, we will position probes of our second multimeter between collector slot of hFE port on our multimeter, and collector terminal on our transistor. We will select DC current measurement on second multimeter in range of 20 milliamperes. Measured collector current is 1.81 milliamperes. So, if we plug in the numbers, we calculate hFE to be around 180. Deviation from direct measurement on multimeter is due to the losses in DuPont wires, breadboard connectors, and multimeter probes connectors. As far as measurements go, this is not so bad a result. In summary, to measure hFE parameter of transistor, we use hFE port on multimeter, and choose hFE with dial selector. Using datasheet for specific transistor, we identify and orient terminals, so they match slots on hFE port on multimeter. When transistor is inserted, and multimeter switched on, display shows measured hFE value. By means of replicating hFE port from multimeter onto the breadboard, we have been able to measure values for VCE, base current, shape of base signal, and verify our measurements by measuring collector current, and then, calculating hFE parameter, based on our measurements and readings. Discrepancy between direct measurement on the multimeter, and our own testing, is due to losses in DuPont wires, connectors, and probes. The same principle applies for testing PNP transistor. Just be sure to properly identify and orient terminals, and choose appropriate slot on hFE port on multimeter of your choice. Please, before you leave, show your appreciation by liking this video, sharing it, leaving a comment, and consider subscribing to the channel. Thank you, and see you next time. Bye.